So welcome you all for tomorrow online classes. We have completed the chapter Electromagnetic Induction. So now today we will solve the NCERT questions of this electromagnetic induction. Yesterday already what are the required concepts and formulas for this electromagnetic induction we have revised. Now in this class, so we will continue with the numericals. Okay na? So let us start. First question. Actually this is in NCERT textbook, this is question number 3. First two questions are there which are based on multiple choice questions. So objective part questions. That questions also they asking how to find out the direction of induced current. The direction can be calculated by using Fleming's rules. Okay. So that making PPT somewhat difficult with the diagram. So directly I am starting with the numericals. That two questions you go through. If any doubts are there, so you can ask in group. So question number 1. What is this question is? So read the questions properly. Concepts, so everything is already we have discussed. So what is the required concept is there that you need to select, then apply it and simplify. So what is this question is? A long solenoid with 15 turns per centimeter. One solenoid is there now. It having 15 turns per centimeter, has a small loop of area 2 centimeter square. Placed inside a solenoid normal to its axis. The current carried by the solenoid changing steadily from 2 amperes to 4 amperes in 0.1 second. What is the induced EMF in the loop while the current is changing? So what is the question they given is, a long solenoid is there now. Solenoid means you know that now. That solenoid having how many number of turns per unit length? So number of turns per unit length, N by L will be equal to, so 15 turns per centimeter, 15 per centimeter. Centimeter means 1 centimeter is 10 power minus 2 meters, which is given by 1500 turns per meter. Turns per meter. Per 1 meter, these many number of turns are there. So per meter has a small loop, one small loop is there. So this loop is there. That loop area they given it as 2 centimeter square. Can I write 2 into 10 to the power of minus 2 meter square? It is placed inside a solenoid normal to the axis. That loop is placed normal to the axis of the solenoid. Okay Nara? The current carried by the solenoid changing they given. So what they asking us to calculate is, so what is the induced EMF? Current value changing from, what is the initial current 2 amperes, the final current is given by 4 amperes, current is changing in a time 0.1 second. Now this loop is placed in this solenoid. So plane of the loop is normal to the axis of the solenoid. If I draw, so normal to which one now? So normal to this loop. Normal to the loop direction will be in the direction of B bar. This is the A bar, this is B bar. How plane of the loop? Plane of the loop is, to draw still properly, that loop they have not given the shape. That loop is perpendicular to which one? This axis of the solenoid. If I draw normal to the loop, the normal to the loop will give you the direction of A bar. So direction of B bar will be along the axis. So B bar and A bar both are along the same line. So theta value will be equal to 0. If I want to calculate the induced EMF according to Faraday law, d phi by dt, which is E d by dt of B bar dot A bar. Since B and A both are in the same direction, so E value d by dt of B into E. So which is given by here A value constant, d by dt of B value given by mu naught into, so what is the magnetic field due to a solenoid? Mu naught into N by L into I. Can I write that? Magnetic field due to solenoid is given by this formula, then which is equal to E is equal to, so A in, or mu naught into N by L, number of turns per unit length, into A into di by dt. Can I write that? So which can be written as mu naught into N divided by L into A into this di by dt can be written as I2 minus I1 by T. Rate of change of current is nothing but final current minus initial current divided by which one? T. So what I will get? E value, mu naught value 4 pi into 10 power minus 7. Correct? N by N value 1500 into area value 2 into 10 power of minus 2 into I2 value 4 minus 2 divided by 0.1. So then you simplify this, what I will get? E value, so 4 pi into, so 10 power of minus 7 into 1500 into 2 into 10 power minus 2 into 2 divided by 0.1. So if you simplify that, you will get the answer. So can I write here a E value given by, so E value I will write in terms of pi only, let us keep it. Then what I will get? The numerator is given by 4 into 15 into 2 into 2. So what I will get? 4 15s are 60, 15 4s are 60, 62s are 120, 62s are 120, 120 into 2s are 240. So what I will get? 240 into pi into 10 power, how much value was there? So 10 power of minus 7, 10 power of plus 2 minus 5, and 10, that plus 2 will be cancelled here, 2 zeros here, 10 power minus 2 cancel, denominator 0.1, 0.1 means 10 power minus 1, 10 power minus 1 will come to numerator, that is 10 power plus 1, so which is given by into 10 power of how much? 10 power of minus 6. So induced EMF units are given by volt. So once you can check it answer also. You can multiply with the pi also. Pi value given by, so 3.14. This is induced EMF. Question understood, Ara? So coil was, loop was placed. Here they not given the loop shape. Simply I called it a loop. But anyhow they given the loop area. The loop is placed axis perpendicular to axis of the solenoid. Are you getting? So we have used totally two formulas. One formula, Faraday laws of electromagnetic induction, and another formula, magnetic field induction due to a solenoid. Question clear, Dara? So this is question number first one. Next, question number 2. Second question. So what is the second question is, a rectangular wire of loop, sides 8 centimeters and 2 centimeters with a small cut is moving out of the region of a uniform magnetic field of Tesla. So external uniform, important question that this is. So magnetic field is there. How the magnetic field is directed normal to the loop. So let me consider magnetic field is perpendicular to plane and passing into the loop. Let me consider one rectangular loop. The rectangular loop is given like this. This rectangular loop having a one cut. So rectangular loop length value, this is of 8 centimeters. So this value of 8 centimeters and this value of 2 centimeters. Now what they are telling is, so that rectangular loop length value given, the breadth value given. What is the magnetic field induction value given? B value 0.3 Tesla. What is the induced EMF developed across the cut? The velocity of the loop. So this loop is started moving. Loop is moving. So loop is moving with a velocity 1 centimeter per second. 1 into 10 power minus 2 meters per second. How loop is moving? Any direction normal to the longer side. Now loop is moving normal to the longer side in one case. In the second case, so loop is moving normal to the smaller side. So this is our loop. Now it is moving normal. This is the velocity. Here this is the direction of the velocity. Clear, Dara? Velocity given. What they are asking us to calculate? How much induced EMF will develop? First case. Induced EMF will develop. So induced EMF will develop here. Which one I need to consider? Induced EMF will be developed across which side? So across longer side or shorter side? Longer side. So induced EMF in your rod formula, E is equal to B into L into E. Why B into L into V? So B, L, V both are perpendicular. So B into L into V. So B value given it as 0.3, L value 8 centimeters, 8 into 10 to the power of minus 2 into V value given by, so V value how much? 1 into 10 power of minus 2. So then what will get E value, which is 8 3 is 0.3. So 2.4 into 10 power minus 4. 10 power minus 4 volt. This is the induced EMF developed whenever it is moving with a velocity v in a direction perpendicular to the longer side. When it is moving perpendicular to longer side, then only the induced EMF will be developed. I told to you, if it is moving so along the direction. Now in this case, why there is no induced EMF across the smaller side? What is the formula for induced EMF will be given by, so B bar dot L bar cross V bar. If L bar and V bar both are parallel, if L bar is parallel to V bar, then E value will be equal to 0. Because cross product of two parallel vectors is 0, that's why induced EMF 0. Whenever it is moving perpendicular to the longer side, the induced EMF will develop across only longer side. So along the smaller side, the induced EMF value will be 0. Now this induced EMF will last in how much time? How much time means the magnetic field is not extended everywhere, the induced EMF will be lost. So induced EMF lost, EMF lost. So after a time, so what is the time value? So time is equal to distance by velocity. Here, so how much distance it has to move to completely come out? So now for example, the magnetic field is extended up to here only. To completely come out, it should travel a distance of 2 centimeters. That is 2 into 10 power minus 2 by velocity value given by, so 1 into 10 power of minus 2. So 10 power minus 2 cancel, then which is of 2 seconds. Within 2 seconds, what happened to the induced EMF? Will lost. Induced EMF will last within how much time? Within the 2 seconds. So this is the first case. Now whereas for the second case, how does the loop is moving? In a direction perpendicular to the smaller side. When it is moving in a direction perpendicular to the smaller side, E value given by, so B into L into V. So this time B value 0.3. What is L value? So L value I want to take this value. This time this is the value. So this is of 2 centimeters. 2 into 10 power of minus 2 into velocity 1 into 10 power minus 2. So answer is given by 0.6 into 10 power minus 4 volt. Are you getting Aram? Whenever if it is moving, so perpendicular to the smaller side, the induced EMF across the longer side will be equal to 0. So how much time? Now what happened? Let us suppose the magnetic field is extended only within the loop. Within how much time the magnetic field, so EMF lost after a time. So after how much time? The time is equal to distance by velocity. So this time it should travel how much distance? 8 centimeters. 8 into 10 to the power of minus 2 by velocity value 1 into 10 power minus 2. So answer is given by 8 seconds. Are you getting Ara? Question clear Ara? First you should get it clearly. When it is moving up perpendicular to the smaller side, why there is no induced EMF across the longer side? The answer for this is induced EMF given by the formula, so B bar dot L bar cross V bar in vector form. If L bar or V bar both are parallel, so E value will be 0. That's why there is no EMF. And one more thing you have to get it is, the EMF will not exist for a long time. Once the loop will come out completely from the magnetic field, flux change value will become 0. That time the induced EMF value will be 0. So induced EMF will last after how much time? So that is given by T. T is equal to D by. Understood? So this is question number 2. Next, question number 3. So what is this third question? So third question is, a 1 centimeter long metallic rod rotated with a angular frequency. I told to you this one. A rod is rotating in external uniform magnetic field. Because I discussed a derivation in the last class, now I can write this formula directly. So rod is rotating in external uniform magnetic field with an angular velocity omega. So what is the rod length given? L value 1 meter. So rotating with an angular velocity omega value 400 radian per second. Okay, Nara? So this end of the rod is in contact with a circular disc, circular metal ring. Constant uniform magnetic field value given it as 0.5 Tesla. So parallel to the axis exists everywhere. What they are asking us to calculate is what is the induced EMF developed. Since rod is connected across the circular ring, so across the ring the induced EMF will develop. That induced EMF is given by E value 1 by 2 into B into omega into L square. Can I write it directly? Whenever a rod of length L rotating in a uniform magnetic field of induction B with an angular velocity omega, so E value given by 1 by 2 into B into omega into L square. Then E value given by 1 by 2 into B value 0.5 omega value 400 into L square value 1 square. So 2 ones are to 200s are. So here what I will get, E value will be equal to 0.5 into 200. So we will get E value will be of 100 volt. Are you getting Ara? For suppose if you don't know this method, this derivation also, so you can use. So what is the linear velocity of the rod given by average linear velocity of the rod? This is I will write a second method. Second method not necessary, just I will write average value 0 plus L into omega by 2, which is, so L into omega by 2. Now see, rod is rotating now. So one end of the rod will be fixed. Linear velocity will be 0. What is the linear velocity of the other end? The distance from here to here is L. Since rod is rotating with an angular velocity omega, relation between the linear velocity and angular velocity V is equal to R into omega. So another end of the linear velocity L into omega by 2, which is L into omega by 2. Now what is B formula? B is equal to induced EMF formula is equal to B into L into V. If I substitute the value of V, I will get 1 by 2 into, so B into omega into L square. 1 by 2 into B into omega into L square. Clear, Dara? So this is the second method. Already I derived this formula. If you don't know means, first you calculate the velocity of the rod, average velocity, then you substitute that average velocity in induced EMF formula or motional EMF BLV. Then you will get the same formula. Okay, Nara? So this is question number 3. Next, question number 4. So what is this question number 4 is, a circular disc of circular coil of radius, a circular coil given. Fourth question, one circular coil is there. That circular coil radius is 8 centimeters, 8 into 10 power minus 2 meters. Having how many number of turns are there? The number of turns are 20. It is rotating about its vertical diameter. It is rotating about its vertical diameter. This is the diameter. With an angular speed, omega value is 50 radian per second. 50 radian per second. In a uniform magnetic field value given 3 into 10 power minus 2 Tesla. So how the magnetic field is there? Obtain the maximum. So now what they are telling is, it is rotating. Let me call, it is rotating in a uniform magnetic field which is perpendicular to plane passing into the paper. Now rod started rotating with an angular velocity omega. So what they are asking us to calculate? Circular coil. They are telling circular coil. Circular coil is rotating. Now what is the question they are asking is, obtain the expression for maximum EMF. So what is the maximum EMF? So we know that whenever a coil, either it may be a circular coil or either it may be a rectangular coil, when the coil is rotating in external uniform magnetic field, The induced EMF given by the formula E is equal to E naught into sin omega t. Can you remember? E value E naught into sin omega t. So E naught is called as N into B into A into omega. So E naught name is called as peak value. The peak value. So what is the maximum EMF given by E naught? What is E naught formula? N into B into A into omega. Can I substitute the values? N value 20. So B value how much? 3 into 10 power of minus 2 into area value pi r square into omega value. So omega value given by 50. You simplify this, you will get E naught, which is given by 2 3s are 6, 2 3s are 6, 6 5s are 30. So 30 into here, otherwise I will write 0. Here this is of 3 into 10 power minus 2. This is 0, this 0, 10 power minus 2 cancel. 2 3s are 6, 6 5s are 30. 30 into pi value 3.14 into r square value. So 64 into 10 power of minus 4. So what I will get the answer for E naught is, so E naught value, this is, so 30, 64 into, you can multiply this now. So which value? 3.14 into 3 is 10 power minus 2. 3 into 3.14 into 64 into 10 power minus 3. So this is the answer. You can multiply this E naught value, which is 12 here. So 3 ones are 3. So 3 4s I will get 9.48 into 64 into 10 power minus 3. So you multiply this, you will get this is the answer for, so peak maximum value of EMF. After completing the maximum value, they are asking us to calculate. The second question is, so what is the average value? Which value? In this fourth only, the second question is, so what is average EMF? Average EMF. Remember here important point is, what is E is equal to E naught into sin omega t. If I plot the graph between E and t, so this is graph is a sinusoidal graph. Here what is the voltage I will get? That voltage value varying sinusoidally, so with the time. Can I write down? So during, this is actually one complete cycle. During positive, during off cycle, the EMF value positive. So during negative, remaining off cycle, it is negative. If I take the average value, you know that. So what is the average value of sine average value, sin omega t? Average value will be equal to 0. We will come to know in AC current chapter. Since average value of sin omega t is 0 for a complete cycle or for one time period, so E value will be equal to 0. Always remember, either AC current or AC voltage value average for one complete cycle will be always equal to 0. Understood, Ara? Now they are telling, so they given the resistance of the coil is 10 ohms. So calculate the maximum value of current in the coil and calculate the average power loss due to the Joule heating. Still two more questions also given. Third one, if the resistance of the coil R is 10 ohms. So they are asking us to calculate what is the maximum current. Maximum current. How can we calculate the maximum current? That maximum current is I naught. I naught is equal to E naught by R. E naught value, you know that now. So what is E naught value? We got so 9.42 9.42 into 64 into 10 power of minus 3 divided by, so what is R value? 10. Then which is I naught value? You multiply 9.42 into 64 into 10 power of minus 4. Multiplication I am leaving to you only. You needed to solve. Okay. So this is the value of which one? Maximum current. In fourth question what they are asking is, so what is the average power loss due to the heating? So power is average value. So average power value is equal to 1 by 2 into E naught into I naught. Why I take an average means 1 by 2. So 1 by 2 into E naught into I naught. That both the values you know. 1 by 2 into E naught value 9.42 into, so 64. Correct, Ara? P is equal to V into I. So this value whole square I will get into, so 10 power of minus 3 into 10 power of minus 4. You simplify this, you will get the power. Okay, Nara? Simple multiplication I am leaving to you. You don't take burden, you are not giving any burden. Simple multiplication. Okay, Nara? This is question number 4. So question number 5. So what is this question they given is, in this question number 5, a horizontal straight wire of 10 meters long extending from east to west, falling with a speed of 5 meters per second, right angle to horizontal component of earth magnetic field. So earth magnetic field horizontal direction. So this is the magnetic field direction, let me call BH. Now one wire is extended, so wire is falling like this direction. So let me call this is east west direction. Now wire is falling with a velocity V bar, the velocity V bar. So wire is falling with a velocity, what they given? So rod length given by L value 10 meters. So it is falling with a speed V is equal to 5 meters per second. In a magnetic field, B value given it as 0.30 into 10 power minus 4. So another unit Weber by meter square. Now what they asking us to calculate in the first question. So what is the induced EMF? Induced EMF given by, since here which are so which are parallel values are given by, so E value given by B into L into V. So what is the value of B? 0.3 into 10 power minus 4 into L value. So what is the value of L? L value given it as 10 into V value given it as 5. So then what I will get the answer given by 0.3, that is 6 na, 5 3 is a 15. 15 into 10 power of minus 4 or 1.5 into 10 power of, so minus 3, that is of volt. So this is the induced EMF which is developed across the rod. Actually what I mean to tell is, so rod is extended from east to west direction and it is falling in a direction perpendicular to the magnetic field. I will draw the diagram still properly. So I will take horizontal magnetic field was present. Okay, na? Like this direction, and this is the direction of the rod extended from east to west, and rod is falling with a velocity V. Here according to the formula, E is equal to, so B bar dot L bar cross B bar. None of the any two quantities are parallel, so that's why induced EMF value is not a 0. Now what I want to calculate is, what is the direction of this induced EMF or induced current direction? Induced current direction can be calculated by which rule? Fleming's right hand rule or left hand rule? So Fleming's right hand rule. According to the Fleming's right hand rule, so direction of the magnetic field here I will consider, since magnetic field is perpendicular to, so length of the rod. So forefinger is indicating the direction of the magnetic field, thumb is indicating the direction of the motion of the conductor. So then what happen? Induced EMF or induced current direction from where to where? West to east. The second one is, so induced current direction, induced EMF or induced current direction, EMF or induced current direction from where to where? Current direction from west to east. Now they are also asking which end will be at high potential. Third question, which end of the wire will be at a high potential. Third question can I write here? Now you see, current is flowing from west to east. I think in NCERT they given answer wrong. Current direction from west to east. But electrons will flow from, so east to west. Electrons will flow from east to west means, so which end will be at a high potential? So west end. West end at a high potential. Okay, Nara? Directions, regarding the direction, I discussed this. So west end will be at which potential? High potential. So this is question number 5. Next. Sixth question. Remaining 1, 6, 7, 8, 3 questions are there. Simple questions. But you needed to apply Fleming's right hand rule properly for finding the direction of this induced EMF or induced current. So last 3 more questions. What are these last 3 more questions are? So question number 6th one. A current in a circuit falls from, in a circuit, current is falling from, so initial current is 5 amperes, the final current is 0 amperes in a time of 0.1 second. So average EMF they given, V average value 200 volt. Now they are asking us to calculate self-inductance of the coil. What is the value? So what is the self-inductance of the coil? How can I calculate induced EMF given means E value is equal to, so in terms of L into di by dt. Actually they given E average. E average value is equal to E by 2 na? E average value they given. So which is average value is equal to, so 1 by 2. Here I need to multiply with 1 by 2. E average value is equal to E by 2. Then E is equal to 2 into E average, which is given by E value. Average value is 200. 2 into 200. Then E value 400. 400 volt. Correct? Now what is the formula? E is equal to L into di by dt. L is equal to E divided by di by dt. So L value, which is 400 divided by di value I1 minus I2 divided by T, which is L value 400 by I1 value how much? I1 value 5 minus 0 divided by 0.1. So what I will get the answer for L? 400 divided by, this is 5 into 0.1. So L value is 800. 0.1 cancel, 5 ones are 5 8s. Okay, Nara? This is question number 6th one. Next, question number 7th one. So a pair of adjacent coils has a mutual induction. 2 adjacent coils are there, so they are having mutual inductance. Question number 7. A pair of adjacent coils are there. This is one coil and this is another coil. This coil connected across the galvanometer, primary, secondary. So that mutual inductance they given it as M, capital M. Capital M value is 1.5 Henry. If the current in one coil changing from 0 to 20 amperes, so initial current value is 0, final current value 20 amperes in a time of 0.5 seconds. What they are asking us to calculate? What is the change in flux linked with the which coil? The change in flux linked with the another coil. Flux change value I want to calculate. Correct? So what is induced EMF formula? E is equal to d phi by dt. So E can be written as M into di by dt. Will be equal to d phi by dt. Can I cancel dt? Then d phi value is M into di. So what is the value of M? Mutual inductance value 1.5. di value given by I2 minus I1. So which is 1.5 into I2 value how much? So 20 0, which is 1.5 into 20, which is 15 2s are 30. So Weber. What is the magnetic flux linked with the coil? Will be equal to 30 Weber. Question understood, Ara? So this is question number 7th one. Last question for this, last question of this chapter itself. NCERT So textbook exercise last question. So that is question number 8. One jet plane is there. That jet plane wings traveling towards west at a speed of. One jet plane is there. That plane wings are given. The wings of the jet plane traveling towards east with a speed. So speed value given it as 1800 kilometers per hour. 1800 into 5 by 18. So 18 ones are 1800s are, which is 500 meters per second. So they asking us to calculate what is the potential difference developed between the ends of the wings. That wings length span that is of 25 meters. They given earth magnetic field given. So earth magnetic field B value will be equal to, can I call it as BE? So BE value will be equal to how much? 5 into 10 power of minus 4 Tesla. And also they given angle of dip, delta value 30 degrees. What is angle of dip? Angle made by earth total magnetic field with a horizontal. In last chapter we studied. So this value. If total earth magnetic field value is BE, then its horizontal component value BE into cos delta. So what is earth horizontal component of magnetic field value? So BH value is equal to BE into cos delta. So what I will get? Now what is the induced EMF? E value. So BH into L into V. BH value BE into cos delta into L into V. Cos delta. So BE value given it as 5 into 10 power minus 4 into cos delta value given it as 30 degrees into length value given it as 25 into velocity value given it as 500. So what is the answer we got? 5 into, so 25 into cos, 25 into 5 is 125, 10 power 100 or 10 power minus 4, cos 120, that is 1 by 2 into 10 power of minus 2. So you multiply this, 2 ones are to 2.5 are. So what I will get the answer for induced EMF, which is equal to 2.5 into 125. So 125 twos are, so that is 125 into 2s are, which is of 250, and 125 half value will be equal to, which is 62.5. So 250 plus 62.5, which is given by 5, here it is of 2, 11, 1. So which is 312.5. 312.5 into 10 power of minus 2, which is 3.125 volt. This is the induced EMF developed across. But remember, what is angle of dip definition? You should get it clearly. Angle made by earth total magnetic field. So with which one now? So with the horizontal. This is they asking what is the induced EMF developed across these wings. When you want to calculate the induced EMF, so you need to measure the horizontal component of earth magnetic field. Okay, this is, and this is about the chapter electromagnetic induction. In the next class we'll start with the new chapter alternating current. Okay na? Thank you.